Welcome back to the Ubuntu server series here at CBT Nuggets. Today we're going to talk about hard drives and partitions. Now, I was going to just include this nugget in with the installation nugget, but I realized there's a lot to talk about when we start diving into partitions and RAID and LVM and all that sort of stuff. So this is its own nugget, and I think it's very informative. So let's go right to pictures that I've drawn, which are most likely horrible pictures, but I'm going to explain these. So first I want to talk about why partitioning schemes are less important nowadays than they used to be. Back in the day, it really mattered exactly how you separated up your hard drives to make for an efficient system. And I want to start with the example of building a campfire. Now, there's the right way and the wrong way to build a campfire. I'm going to say the right way, and since I can't hear what you're saying, I kind of have the la 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 fingers in my ears kind of thing going on. So if you disagree with me, I'm never going to know. Basically, the way my wife builds a campfire is she takes all of the logs and she leans them into a little teepee shaped thing. In fact, this is called the teepee method for building a campfire, right? You just lean all the stuff in there. You light the fire, and the fire burns down, and you keep leaning stuff in on it. Now, this is bad for a couple of reasons. My ideal way to build a campfire is with the log cabin method. So basically, you have a very stable log structure crisscrossing back and forth. The fire emanates from the middle, and you get a nice even burn. When they start to collapse, they collapse in on themselves in the middle of the logs. The fire contains itself into the pit, makes a nice bed of coals. This is the proper way, according to me, but not my wife. See if I can make a thumbs up sign. This is the proper way to build a fire. That's a thumbs up, just so you know. The reason that this is bad is not just because I don't like it, but I personally don't like it when the stuff falls over. In fact, if I were making a case, I would say that if one of these logs falls over in the wrong way, it could create a a catapult, and launch fire across the yard, starting a forest fire. And so basically the TP method is just, it's dangerous for everybody, right? No, actually we all know better. We know that right now there's more gas fireplaces anymore than there are log fireplaces anyway. But nonetheless, this is my silly example of why organization matters. Same thing with, let's say you're a barbecue person. If this is my Weber smoker grill, these are the charcoal briquettes. If you throw them all over the place, you get uneven heating. You get a hot spot here, ice cold in the middle, so that the burger that's placed right here is raw, and these are tiny little burned up burgers, possibly on fire. So this is the wrong way. If it's properly stacked up into this nice pyramid, once it gets hot, you can spread them all out and you get a nice even flame. But just like with this, we know that most grills now are gas grills, which tend to heat evenly. All right. Now that brings us to the whole point of this nugget. So pretty much you can ignore everything I've just talked about unless you really want to have an argument with people about the proper way and the incorrect way of building a campfire. But when it comes to partitioning, it used to be that you would have one drive. Let's say it was 20 gigabytes, or you might, if you were rich or had a really expensive server, have two drives. And what you would have to do is decide where you would best split up information on here so that both drives were being used optimally and not one being used constantly and one not being used constantly. Okay? So the problem is this isn't really the case anymore. Nowadays we either have lots of very large capacity drives that we split up, or more commonly, we actually have a SAN where all of the data is pooled together and split up logically, or even an SSD where partitions don't matter because they spread data across the entire physical space of their storage anyway. So partitioning is much less important than it used to be for performance sake. You can still do it if you want to split them across drives, but it's generally not the way things are done anymore as far as for speed or reliability or planning goes. Okay, so this is why partitioning is less important. What I want to talk about now is what sort of partitions are we talking about on the drive? So when we talk about partitions on a Linux system, we're talking about where files are stored and how those are split up. In the Windows world, it would be the A drive and the C drive and the D drive and the E drive and the Z drive. In Linux, it's all partitions. Basically, you mount a drive as a folder in the file system space. So think of, you can have a folder, or that folder could be an entirely different hard drive. And the partitions, now there's a ton of partitions that can be defined, and in the olden days there were like probably a dozen that were commonly used. I'm going to talk about the major ones that you should probably understand at least what they do. Now, just the slash, just the root partition. So this is going to be the catch-all where everything goes. Remember, it's just a file system. So at the root level is where everything goes unless it's somewhere else. Unless you decide, I'm going to put a hard drive at the boot folder or the boot level of the file system, well then it's not going to be stored on the same physical media that the root level is. It's going to be on its own media. So the boot is a partition. Now, back in the old days, I don't know, not that long ago, maybe 10 years ago, you had to have a boot partition that was under a certain amount of megabytes, or the system couldn't load its RAM disk. It was really complex. Basically, you would just create a boot partition that had like 100 megs and life was good. Now, you don't really have to do this anymore. Every modern computer, in fact, even not so modern computers now, you can just put the boot folder on the root of the system and it's going to be able to boot just fine in general. All right, so generally we don't have to worry about a separate boot partition. There are some cases where you'd want it, but for the most part you just have the boot as a folder inside the root partition. Now, this is where we start talking about, remember we would have a couple drives in my last slide over here? Here, I'll go back. So here where we had like 2 drives in the entire system, well, in order to split up the load so that they were both doing disk I/O about equally, what we would do is we would say the user partition. Now, the user partition is where programs are generally installed. So like user bin, this is where the binary programs are stored. If you install a program, it installs its stuff in the user partition. And basically that would get a lot of read I/O because it would be constantly reading all of the data in that user folder when it launched programs. Okay, but you wouldn't generally write to this very much, if at all. In fact, sometimes you could even mount this read-only because you almost never had to write anything to the user directory unless you were installing something. But in general, it gets a lot of read I/O, very little write I/O. Now, the home partition, or home directory if you don't have it as a separate partition, but the home partition or the home directory gets lots of I/O. It gets lots of read I/O and lots of write I/O. So this is something that you would generally put on its own drive. So back here in my other slide, we may dedicate this entire drive to the home directory where users' files are stored, retrieved, saved, configuration files are all managed constantly. Lots and lots of disk I/O in the home partition, so sometimes that would be a separate disk altogether. And then the var partition. This is where mail comes in. This is where log files are stored. This is where print jobs. Did I already say that? Print jobs, mail, logs. Lots of stuff written to this file system, and some read. When you read your mail, obviously you're reading stuff off of the drive, but the majority of stuff in the var partition was write I/O. So a crafty sysadmin saying, I only have 2 drives, I know that the home partition is just going to get hammered with my users writing and reading constantly. Well, maybe I could put the user partition and the var partition, maybe they could all be on one drive. Well, that way it's doing both reading and writing, but since this one writes more and this one reads more, reads and writes on a SCSI drive, it can do both simultaneously, so maybe that's a way that I would efficiently use my disks. Do you see how these two maybe would be tied together, and then this one would be separate? Back here, so this one would be cut in half. Half would be user, half would be var. And that would be a common way to make sure that the disk I/O here and the disk I/O here were about even. All right, that's just an example. Depends on what your server's doing, and you just have to know what it is that your server is going to be reading and writing in order to best plan those things. But it's becoming much and much less of a point. We'll talk about that in a second. Lastly, the temp folder. This is often, it depends on what kind of system you have. Maybe you want this to be on its own partition or its own disk. Not necessarily for I/O reasons. Yes, it gets lots of I/O, but sometimes the temp partition will fill up, and if it fills up, well, it can cause some errors. But if it fills up your entire root, and then all of your stuff starts failing because of the hard drive being full, sometimes it's good to have temp on its own partition or its own drive. Okay, that would be an example of why you would want that separate from the root folder. And then lastly, swap. It's not really a part. Well, I guess it is a partition, but there's no file system on it. This is, if you're a Windows person, the swap partition is the same thing as a page file in Windows. You dedicate a partition on the drive to swap, and it gets lots of I/O if there's undersized RAM. Okay, normally the swap partition doesn't do much; it just sits there. But if you have undersized RAM, you don't have enough RAM sticks in your server for what it's doing, or at one particular time it starts eating a bunch of RAM, this I/O is going to skyrocket and possibly cause your system to slow down. So the swap partition is sometimes on its own fast drive if you don't have enough RAM. So that's partitions in a giant nutshell. But remember, since we're starting to do things like a SAN or even SSDs, sometimes splitting these up doesn't matter. And the reason, I'll give you an example with an SSD. If this is an SSD, it doesn't matter how you split it up. The SSD logic is going to evenly distribute reads and writes all across the medium so that it doesn't wear out in one spot over the other. It's all going to be done behind the scenes with its firmware. Okay, so again, partitioning is less and less important. Same thing with a SAN. A SAN has lots of drives inside, and it does all the logical, okay, this is it'll say, okay, this is your drive, and you just believe that that's your drive, but you don't know what it's doing. It's actually probably striping it across a bunch of drives in the background, and you just use this virtual drive hunk, and you just know that it's going to do its best to align reads and writes across the proper medium. So it's becoming less and less important to know and plan partitioning schemes, but now you're a pro. Now you know, and maybe you have a situation where you should set this up in a specific way so that you know your server is going to be doing something that is going to really benefit from having one of these things partitioned off on its own drive or its own partition on a hard drive. But, isn't there always a but? What if you work in a situation where you don't have a SAN? For example, I've been a system administrator for about 20 years, Linux system administrator, and I've never been in a situation where I had a real SAN. My network just hasn't been big enough. However, I have used RAID and LVM. Although I have a confession to make, I've always avoided LVM like the plague, and it's not because it doesn't work, and it's not because it isn't an awesome tool, it's because I didn't understand it. And once I forced myself to learn about LVM, I can't believe that I avoided it for so long. It is just amazing. Now, it's different. A lot of people confuse RAID and LVM because some of what they do is similar, but they're very different, and they work really well together. So RAID, a redundant array of independent disks or drives. What RAID does is it provides you with increased performance over individual drives and or increased reliability over those drives. So, for example, let's say we have, these are 3 different scenarios on the same computer. We have 4 hard drives. These are physical hard drives, 20 gigabytes each. Okay, with RAID 1, what RAID 1 means is it's a mirror, 1-to-1 mirror. And what it does is it says, okay, for every time I write something here, I'm going to write it over here. Every time I read something here, I'm going to read it from here, make sure it matches. And basically, it just keeps 2 copies of everything you do. So if you have 4 20 gig drives, with RAID 1, you only can use half of the total storage. Does that make sense? So you stack these on top of each other, and you have 40 gigs of usable space because every time you write something, it writes it to 2 different drives. So if you write a 20 gig file, it's going to fill up this drive and this drive. Another 20 gig file, it's going to fill up this drive and this drive. So when you use mirroring, you only get half of the total storage usable. However, the really cool part is, so this is what happens. Let's say both of these drives, let's say that somebody builds a TP Fire over here, and a coal launches over and catches these 2 drives on fire, and these are completely destroyed. Well, hey, that's all right because we still have 40 gigs of complete storage right here. Everything's safe. All right, so this provides reliability. RAID 0 provides performance. What this does is, let's say you're writing a file, okay? And we have the 420 gig drives again. In RAID 0, this stripes the reads and writes across the drives. So instead of saying, okay, I'm going to write a file, write a really long file, what it does is it cuts the data into 4 bits and it writes across 4 at one time. So instead of writing one file to one drive, you're writing a fourth of that file across 4 drives, and you get 4 times as fast, in theory anyway. But does that make sense? You instead of writing one file at a time on one drive, all of your drives are working together to save the data. So they're all storing at the same time. Now, this is great because since the data isn't duplicated anywhere, it's just striped across the drives, you get the full 80 gigs of storage. Right? Although the bad news is all it takes is one little ember from that poorly created TP fire to come over, destroy this drive, and all of your data is lost. Because that one file that was written across all 4 drives, you only have 3/4 of that file, and 3/4 of a file is nothing. It's garbage. And the RAID 0 array doesn't even know how to get that back. And then lastly, we'll talk about RAID 5. RAID 5. So, and there are a couple other, you can combine 1 and 0 for mirrored striping, but in general, these are the basics. RAID 5 does some really cool magic that, I'll be honest, I don't quite understand. Okay? It does the same thing where it writes across drives, but then it has one magical drive called the parity drive. And what it does is it stores all the data across all the drives, just like a RAID 0 drive. However, using this parity of all the drives, somehow it manages so that if you get, let's say, one of these drives fails, this drive catches on fire, completely fails, you still have your data. Because it's stored enough information across the rest of the drives that it still has your data over the other 3 drives. So you lose that one drive for parity's sake. So it means in our 420 gig drive scenario, we have 60 gigs of usable drive, and up to 1 hard drive can completely fail and you don't lose any data. So that's how RAID does performance and reliability. All right. LVM is completely different, sort of. It provides flexibility and a little bit of sanity. All right. Now for RAID, you'll notice all of our drives are the same size. Oh, that's important because no matter what it's doing, they have to be the same size. Drives or partitions. Now with LVM, it's Logical Volume Management, or Logical Volume Manager, LVM. And what this does is it allows you to take a bunch of storage. Okay, so let's say I have a 10 gig drive, a 40 gig drive, an 80 gig drive, and a 300 gig drive. And it allows you to pool them together into 430 gigs of storage. And then your computer sees this as just one giant drive, and then you partition that up. It's sort of like a mini SAN, right? It does this and then allows you to cut it up. Now, just like RAID 0, if these are actual hard drives and you have one fail, you are in trouble, because it's just like you may have heard of just a bunch of disks, and basically if one of these fails, all of your data is doomed, and that's a scary thought. So in general, the best possible scenario, and sanity. Sanity just means instead of managing all these drives, you just have a big chunk of storage, okay? Big chunk of storage that you can manage, and that provides some sanity. And the flexibility comes because, let's say in 2 months you realize that you have to add a 500 gig drive because you don't have enough. Well, with LVM, you just extend this drive, and then bam, all of a sudden you have, I could have just done this. All of a sudden you have 930 gigs of storage, and then you can split that up. So that's where the flexibility comes into play. But in the ideal world, what you want to do is combine RAID and LVM so that you get the advantage of performance and reliability here and this flexibility and sanity here. So this 40 gig hard drive, well, it doesn't have to actually be a hard drive. That 40 gig hard drive can be this RAID 1 array that we've done. So now we can still have Drives fail in our 930 gigs is fine because again, this piece of the LVM storage is a RAID array. And if all of these are RAID arrays, then you're safe. And that's the setup that I've done. We're going to look at in just a second. Okay, so I hope that you understand that these are different things. They don't do the same thing. They're there for different reasons, and they work best when they're used together. All right. If you've been afraid of using LVM for years because it seemed complex and it added a layer of complexity to an already scary endeavor dealing with hard drives, I got to tell you, I did the same thing. I thought, why would I add a layer of complexity onto, one more spot for it to fail? Why would I do that? In fact, in some of my writing over the past years, I may have even said things like, just avoid LVM. It's another layer of complexity for things to fail. I was wrong. LVM is powerful and awesome. All right, so I've set up our test system with RAID and LVM. I want to look at it because we've been looking at my silly slides for a long time. All right, so I want to describe our system, and then I'm going to show it to you. Now, I know that this nugget is getting long. Just bear with me for this slide, and then we'll go to the command line, check out what's been done, and move on. I just think the concepts are so important. I really want you to get it. I want you to go into our installation understanding what's going on the underlying system. Okay, so our system, we've looked at it in the last nugget, the server system that we have running Ubuntu server. Now the main drive is a 20 gigabit drive, and actually for me it's a virtual drive, but for this, it doesn't matter for this case. Just we'll say it's a 20 gig physical drive, and it's dev SDA. This is where the drive is located on our system. Okay, if you're unfamiliar, drives, every bit of hardware in the Linux world is also defined by a file system location. So dev SDA is actually the physical hard drive. All right, and this is cut up into a few partitions. SDA1, which is our root partition, and then SDA2 and 5. Now, if you're familiar with partitioning schemes, there's the primary and then the extended partitions on a drive. It gets a little confusing. Just know that we have the root partition and then we have the swap partition. This SDA2, it just allows us to use an extended partition. It's what Ubuntu does by default, but it gets a little confusing. This is basically our swap partition. This is our root partition, and that's it. By default, that is all Ubuntu server did, because again, we're getting past the world where partition specifications are so important. All right, so that's our system. What I did is I added 10 more, or I didn't, sorry, not 10. I added 4 more drives, 10 gigabytes each. So dev SDB, dev SDC, SDD, and SDE. That's an E, in case you can't see that. These are all 10 gigabyte hard drives. And I've partitioned them using, and I created the partition of type Linux RAID. So this will be done during the install. You won't actually have to do this, but if you want to do it after the fact, it's something to look into. So I've created the partition, the first partition, a primary partition is all I've created, and I've made it type Linux RAID on all 4 drives. So all of these drives have one partition, and it's the type Linux RAID, software RAID. And then what I did is with drives B and C, I created a RAID 1 mirror, and that device is called dev MD0. With these 2 drives, I created a RAID 1 mirror array, and it's called MD1. So now I have 2 RAID mirror devices on the drive. So MD0 is a device that has how many gigabytes available? Remember, it's a mirror. So I only have 10. So this is a 10 gigabyte mirror. This is a 10 gigabyte mirror. And I've combined them into an LVM. At this point, so this is all the RAID stuff. This is the LVM stuff. I've combined MD0 and MD1 into a volume group called dev storage pool with 20 gigs total. Does that make sense? Each one of these is 10. So 20 gigs total in the storage pool. And then the system treats dev storage pool as if it were a hard drive. So even though it's a volume group with LVM, the system, the Linux system, treats it as though this is a hard drive. And I've created a logical volume called FlexiDrive that's 15 gigabytes. Okay, so hopefully that makes sense, and we're going to look at it on the command line. And then the cool part is, so then this storage pool still has how much room available? Well, there's still 5 gigs of space on this volume group that I'll be able to peel out. And if I have a drive fail, well, that's okay because they're RAID devices. And if I fix it at the RAID level, up here at the LVM level, it'll never know, right? It'll just know, well, my 2 hard drives are MD0 and MD1, and they're perfectly fine. All right, so let's go to the command line, see what this looks like on the system. And don't worry if you're like, how did you do all that stuff? We're going to do it during the install. So don't worry about that. I just want you to understand what we're doing before we do it. Okay, here we are at our server, and it's big and blocky because I didn't want to add the complexity of logging into the Xubuntu desktop server. So we're at the raw server. Okay, and what I want to show you is a couple things. I want to show you on the system what we just looked at on that slide. So let's do ls-l dev sd star. So what we have here is we have this is the SDA. This is again our 20 gig drive. These are the partitions I explained. This is the root partition. 2 and 5, it's an extended partition and swap. So this is where our system itself is installed. And then these are the 4 drives I added: SDB, SDB1, SDC, SDC1. The 1, this is the partition I created of the Linux RAID partitions, right? So SDC is the actual drive. SDC1 is the partition I created on that drive of type Linux RAID on all 4 drives. Okay, so those are the devices, the physical devices in our machine. And now, if we look at the RAID arrays, we can type looking at proc mdstat. It's a shortcut way to actually look at the MDADM process, right? The Linux RAID process, and we have 2 devices: MD0, active RAID 1, and it has these 2 slices, B and C, right? SDB1, SDC1, just like our drawing showed us. All right, and 2 out of 2 are active. We're in good shape. It's working. This is fine. Same thing with MD1, except this is using 2 other drives. It's using SDD1 and SDE1 partitions from up here. And so each of these, MD0, MD1, are RAID 1 mirrored devices. All right. As far as the computer is concerned, these are hard drives, 10 gigabyte hard drives. The system doesn't realize that they're really RAID arrays. It just knows that it can treat it like a hard drive. All right, and lastly, what we want to look at are the LVM group that I made. So I want to look at PV display, and what this is going to look at is the physical volume display. So physical volume, PV is physical volume in the LVM world. Hit enter, and it's going to show us 2 physical volumes. Again, it thinks that they are hard drive devices. Dev MD0, partition 1. And it's in the volume group storage pool. It's 10 gigs, right? 9.99 gigs. And the other physical volume, PV, is dev MD1, partition 1. On this device, I had to create partitions, LVM partitions. It's part of the volume group storage pool, just like in our drawing. It's also 10 gigs. So total, we have how many gigs available in the storage pool if we add it together? Well, 10 plus 10, so we have 20 gigs total in the storage pool, just like our driver, or just like on our drawing, right? And now one last thing to look at is the LV display, and this is going to be the logical volume display. So of that 20 gigs storage pool, LVM, that I've created, I've chopped it, and one of the hunks that I've taken off is called FlexiDrive. And FlexiDrive is 15 gigabytes in size. It's read-write access, and I can treat dev storage pool FlexiDrive just like a hard drive in my system. So as far as my Ubuntu system knows, dev storage pool FlexiDrive is a hard drive. I can format this, I can mount it, I can do everything I could do with a regular physical hard drive. However, I've added security, or I've added reliability rather, with the RAID mirror, and I've pooled them together so that I've allowed myself to use those drives and just carve out of the big storage pool hunk. I can grow storage pool by adding more drives. I can shrink it. I can add, another drive and then add to FlexiDrive and make FlexiDrive bigger. That's the advantage of LVM, is it allows you to move data around. It kind of virtualizes your storage. It's almost like a software version of SAN, right? If Linux RAID is software RAID, LVM is kind of like software SAN on your local computer. All right, let's make sure that you understand that last slide, and then we'll move on to the next nugget. I know this has been a doozy. Okay, so we have two things going on. Remember, we have RAID, where we have created two mirrors with our system, and then with those two mirrors, we've created a logical volume, right? We've actually created a volume group, storage pool, and chopped a hunk off a logical volume called FlexiShare, okay? Or FlexiDrive, I'm sorry. So that's what we've done. Here is the actual illustration of our system. These are the 4 physical drives. We've taken and made 2 different mirrors. So these 2 drives are mirrored, these 2 drives are mirrored to create RAID mirror devices. In those 2 RAID mirror devices, we've put into a volume group called Dev Storage Pool, which gives us 20 gigs total to play with. And I decided to carve off a chunk, a logical volume of storage pool, and it's called FlexiDrive. So Dev Storage Pool FlexiDrive is a 15 gigabyte hard drive as far as our system is concerned, and we'll treat that just like a hard drive. Okay, I know it was confusing, but we're going to actually see how the installer itself handles things like LVM. But for the immediate, I want to make sure you understand the difference between RAID and LVM, and I want to make sure you understand what partitioning is and why it's not quite as important as it used to be to separate them out, but it might be. So maybe for you, the whole idea of these partitions like a home directory, maybe that is something that you'll need. I hope that this has been informative for you, and I would like to thank you for viewing.